final topic that we're going to discuss in this opening section is the idea of a function and how is it different from a relation. Putting the relation back in our head, a relation is a set of ordered pairs. So as long as you have an input and output or an ordered pair, remember it was basically the concept of if I give you an input value x, it'll give you an output value y. A relation is an ordered pair. We're going to distinguish between a relation and a function here in a moment. There are different ways of expressing a relation. A relation can be seen as a set of ordered pairs. So that's one representation. We can write all of our ordered pairs down in a list. Another way that we can view a relation is through a table. So a lot of times we'll look at data and analyze it through a table, but the x is nothing more than your input value here, and this is your output value there, so that your inputs are always your domains, and this is your range. So there's not a big deal here. It's just a matter of how we're going to look at it. It may look differently, but we're still looking at the same sets of ordered pairs in the same relation that we're building. The relation can be looked at as a graph. We just saw in our last example that we can definitely graph these. So if we're going to graph the ordered pair 1, 2, we'd have to go start at the origin, go 1 to the right, up 2. So this is the ordered pair 1, 2. And then if we wanted to graph the ordered pair negative 2, 3, negative 2 means we have to go 2 units to the left, so 1, 2, and then up 1, 2, 3. So there's our ordered pair negative 2, 3. Reviewing our quadrant, that landed us in quadrant 2. We started the first one in quadrant 1, and so on. So we're looking at a graph can represent a relation as well. So you got to think of different representations of relations. And the final one is a mapping, and these are called arrow mappings, or at least that's what we like to think of them as. But a mapping shows us how one value is mapped onto another by applying a rule or by applying some type of criteria. So we're going to map 1 onto 2. We're going to map negative 2 onto 3. So we're showing how the input in the domain gets mapped to or paired with the output in the domain. So this first thing that we're looking at here is there's really 4 different ways of visualizing or seeing, representing a relation. So now, let's get to our last topic here, a function. So a relation is any set of ordered pairs, but a function is a very specific one. So now we're going to get some more rules. A function is a very specific relation. So basically, it's a special type of relation. So a relation is very loose, but a function starts to get some restrictions on here. So we're going to restrict what a relation can be. It says a function of a relation is in which each element, and I like to, instead of the word each, you could put in every element, and that's pretty important, that each and every element in the domain. And remember, your domain are your inputs. So as long as every input, every x value is paired with exactly, and here's italicized, so it must be important, exactly one element of the range. So one member of your outputs, which are your ranges. So we got a lot of vocabulary coming at us in a short amount of time here, but none of them should be terribly new. So what have we talked about here as a function? A function says for every input, there must be one output. So really another way of describing a function is for every input, there is exactly one output. Okay, so now I'm using the words inputs and outputs. You could, for every x, there is exactly one y. Or for every member of the domain, there is exactly one member that's partnered up with it out of the range. So for every input, there's exactly one output. So let's see if we can put this into practice. First thing, it says state the domain and range of each relation. Then determine whether the relation is a function, right, yes or no. So in problem number 1, they want us to state the domain and the range. So I'm going to use D and R. What's in the domain? Well, the domain is everything in the first member of the ordered pair. So all our x values, it's a 2, it's a 3, and it's a 1. The range, I want to grab the things that are in the range. And that's a 7, 10, and a 6. So I've identified the domain and range. Now I want to see, does this relation represent a function? does it adequately meet the definition of function? Is for every input, is it paired with exactly one member of the output? And I look at the ordered pairs, and I know that the 2 is paired only with the 7. It never gets paired with anything else. The 3 gets paired with the 10, and the 1 gets paired with the 6 only. So this is yes, it is a function. Because for every input, there's exactly one output. Let's look at example, I guess we'll go to number 3 is what I came to next, and we'll happen to 2. But in example number 3, the 1 gets paired with the 5, so we're going to look at our domain and the range. It's just a different way of organizing, look at the data in a table. So we got 1, we got a 2, and we got another 1. Since 1's already occurred once, I wouldn't have to put it down twice. I could get by with listing it in my domain. There's a 1 and a 2 in the domain. There's no reason to write it down twice. In the range, we have a 5, a 7, and a 9. So there's our domain and range. Is it a function? So now we've got to determine, does it fit in this definition of a function? Does every input get paired with exactly one output? And that answer is no. The 1 gets paired with a 5, and the 1 gets paired with a 9. So this 1 gets paired with the 5, and it gets paired with the 9, so not every member. The 1 did not get paired with exactly one member of the domain. So is this a function? No, it is not. And the reason is because 1 is paired with 2 outputs. 1 has 2 outputs. Or 1's got 2 members of the range. Okay, we'll go look at number 5. Couple left. They're just showing you different representations of relations. So let's go with this representation. We've got a mapping. So we got our domain and our range that we're going to identify. Our domain is a set of numbers that contains 3, -1, 0, and -2. The range has a set of values that is 2, -3, -2. Now we want to determine whether or not this is a function. Just keep in mind what your function definition is. Adhere to it strictly, and it says, does every member of this domain get paired with exactly one member of the range? Does 3 get paired with exactly one member? Yes, it's a 2. Does a -1 get paired with exactly one member? Yes, it's a 2. It doesn't matter they both get paired with a 2, it's just that each of these gets paired with 1, and obviously 0 gets paired with a -3, and -2 gets paired with a -2. So is this a function? Yes, it is, because every member of the input gets paired with a single output out of the range. We'll look at one final example, and this example is an example of a graph. Remember, we can represent relations graphically. So we can state the domain and range of this, but before I do that, it might be helpful to put in our x and y axis. I want to be able to see a little bit better than I can there. So I'm going to look at these ordered pairs. It's the ordered pair 1, 2. So I got the ordered pair 1, 2. So the other ordered pair that I have here is 1, 2, 3. We have another ordered pair here that is 3, 4. So I'd like to see the ordered pairs on my graph as I do this. And on this point that I'm looking at here, we're going to go 1 to the right and then down 1. So that's 1, -1. And then this ordered pair here is left and right 0, so I have to have the ordered pair 0, and then we went down to -2. And this ordered pair is a -1 since we went to the left of the origin. Here's their origin. So we went left 1 and then down 1, 2, 3. It's -1, 3. Okay, so now I've got my ordered pairs, and I'm going to go use those ordered pairs to help me identify the domain and range. The domain and the range. Whenever I get to a graph, I'm going to write down those ordered pairs because then it's going to be easier for me to grab those domains and ranges. So the domains are all these first guys of the ordered pairs. So I got a -1, 0, a 1. Now the 1 gets used twice, so I'm only going to write it once. We got a 2 and a 3. Then the ranges are, we had a -3, and I don't know if I did that right. I don't know if I put a negative on that 3, -1, -3, so just correcting that, -3. Then we got a -2, -1, 2, 3, and a 4. I'll double check so I got all those. Got negative 3, negative 2, negative 1, 2, 3, and 4. Got them all. Okay, so we got their domain and range, so our final question is, does it represent a function? Okay, so function, yes or no? Does every member of the inputs, does every XA get paired with exactly one output? And here's where we have a problem. I'm going to look at this specific pairing right here. The 1 got paired with a 2. So 1 got paired with a 2. I'm going to use a kind of an adaptive arrow graph. And the 1 also got paired with a negative 1. So this one input got paired with 2 different outputs, so it is not a function. Anytime a member of the domain up here is paired with multiple members of the range down below, it cannot be a function. So function is a special type of relation. You got to make sure that you understand what it's asking whenever they're asking you for information about a function. That concludes this lesson, and now you come back tomorrow, we'll look at doing your homework in class, and I can answer questions you may have about the video I produced here. So we'll see you tomorrow. Thanks. Bye.